Hello, Mike. So I wanted to record this video so I can show you the results in the IDEA StatiCa Detail model that I prepared for you. So just a reminder, we created this model with this force or load combination, right? And then we created this kind of big concrete block. So whenever we export it to detail, we can use some operations in detail 3D to create that shape that you have on that drawing, right? So once I export it, remember that you can do that under the check tab here. You select RC check, and then that will create a detailed 3D model. Then if I go here, this is already analyzed. So here you can see some results, but before checking those or reviewing those, let's take a look at this, the methodology that I used to model this shape. So CB, this is concrete block 1. That is basically the concrete block that was imported from connection. And then later I started adding negative volume. So that is how we create this shape of the foundation, right? So I'm going to show you in this solid block view, so you can see it like that. So you can see the original shape of that concrete block, and then I created this multiple negative volumes. Okay, so you can create them here while adding a new model entity, and then you define the dimensions in this area, and then you can define it from different surfaces and then related to edges. The surfaces in the software will be the ones in brackets, then the bracket, the number in bracket. Okay, the edges will be the edges of that surface. Okay, so that this, you can see 1, 2, 3, and 4 from surface 1. Anyway, after you create this, my approach is by creating this sequentially, right? So that means I create this negative volume, and then I add this cut operation. So then I'm cutting the member CB1 by negative volume 1. And then I go ahead and create now the second negative volume. And basically what I did is I start copying this negative volumes and then set it up from there. So that was the process I follow, and then adding a cut operation and so on. So you can see the sequence of the modeling of this negative volumes and then cuts. Then later, if we go into the, let me turn off the rebars and show you the transparent mode. Later, when we go into the supports, I model 2 supports. One is at the base of this foundation, and for that one, I activated the compression only support. So this will create a support, compression only spring support, right? And that means whenever there is a tension as a reaction in that support, the analysis will be finished, right? So that can only handle the tension, sorry, the compression reactions. Then the other support that I added here is on this grade beam, concrete grade beam. Why? Because we're supposing this is continuous through the length, right? So that'll be continuous. I just put the support in the beam, let's say cross section. This is by creating a support on surface 1, and then I edit this shape and then use this X and Y translation input, so I can move that rectangle, let's say that rectangle representing this support. So you can see this shape over here, and that will be the shape that I created. Transfer devices, there is nothing we do with those because we imported those from connection, so they will be brought over automatically. Load cases, similar. There is nothing we can do about this because we brought over from connection. So that's why it's important you set it up first in connection and then you import this. So this is imported automatically into the base plate and then into the anchors if you have some tension forces on the anchors. So nothing to do on those load cases. After that, after you create kind of the shape, you create the supports, then now we can jump into the reinforcement. Okay, so the way we add the way I added this reinforcement is through this group of bars operation, and you can see them here in this model. So I'm going to show it to you. This is basically modeling the stirrups. So it can be confusing with this end condition, but basically that end condition is this anchorage type that I selected at the beginning at the end of this grid of rivers. But you can see that I created, let me put it in the 3D view again. I created two basically I created 12 layers, so that's the number of let me put it again in this 3D. I created 12 layers of rebars with 2 bars in each layer. So it's 1, 2, 3, and then 12 in this direction, right? And then 2 bars, 1 at the top, 1 at the bottom. So you can use that to create this kind of grid. So this is in one direction. This is on surface 1, H1, so they are following this longitudinal direction. Then the other group of bars that I created is in the other direction. So this is basically to create the top and bottom grid of rivers. Then for the beam, let's put it in this view here. I created 3 layers. The distance between these layers is 2 inches, and I have 2 bars in this layer. So basically, this is to model the beam reinforcement. At one end, I put this as a continuous because this will continue through this element, let's say, but we are not going to model the entire beam. So by modeling this continuous rebar, it helps us to kind of anchor or make this this reinforcement continuous, so it's perfectly anchored to the other side, right? Then at this side, we're going to use this anchorage type, which it has a 90-degree hook. Remember that this setup is just a graphical representation. What it does, like analytically, is changing the spring factor that is at the end of that rebar. So that will represent the connection between the end of this rebar to the concrete. Okay, so the first option, it means there is any connection between the end of the rebar and the concrete. Then this to this 90 degrees and 180 degrees hook is representing 0.3 times the spring. So it's anchored to the concrete 30%, let's say. And then the last two, the perfect bond and then the continuous, is representing perfectly bonded. So that means 100% of the connection, right? We're connecting totally to the concrete. So that is how we represent this anchorage and what is the analytical value. Okay. So I did the same in the bottom side to have the other rebar in the bottom side of this beam. Again, this seems messy, but don't worry, this is just a graphical representation. Actually, when you see the results, you won't see this bent parts. You're just going to see kind of a straight bar, but analytical, the bond strength at the end, you will see different values if you select this hook or the free end. Okay. Now I created this vertical reinforcement for the pedestal. Okay. And finally, I created the stirrups for this pedestal. Okay. So again, you will have the model. You can review it and see how I modeled this. Right now, I turn off the rebars here, but you can activate them and then see them at all at the same time. If you unactivate this, then you can navigate through these different rebars. All right. Now, the trick that I use here to have a faster analysis is that I change this mesh setting to have a default mesh size of 5. So this is a multiplier only. So this will increase the size of the elements of this 3D block, of this 3D FEA block mesh size. Okay, so this is just to speed the analysis. So in an initial calculation, you don't have to wait too much for the results. So after I click calculate, then this is the results I got. The analysis stopped at 44.2% of the applied loads. So this means something of these 4 items fail. In this case, the reinforcement failed, and also the anchorage was close to 100% of utilization. Here, you will see why it fails. So it's telling you something. So concrete crushing at the anchor concrete interface due to the shear has reached the limit. So this tells you something. If you go now to the check tab, then what we can see here, actually this is useful. This is activated because I was reading this deformation, but you can always come here to the auxiliary results and see the deformation. It doesn't matter if we just have strength combination, you can always see how this is deformed due to the applied loads. And of course, this is deforming like this because we have a very high shear force in that direction, right? So if we go here, remember that we have this force of 165 kips on this beam element. Okay, so remember that this is the results of this calculation. Let me see the deformed shape. Remember that here also it's helpful to see the deformed shape. All right, so that's that. And the first result, whenever you click over check, you saw the deformation because I was there before, but the first result that you will see is this summary. Okay, so this will show you the stress flow. So the red lines is representing the compressive stress on the concrete, and then the tension force is being captured or is being taken by the reinforcement. So you can see the utilization on the rebars. Okay, but here we have this icon that's called failing element. So when you click over that one, this will tell you where is this issue that it was highlighting the concrete crushing. Okay, so there is a crushing between the anchor because we are transferring the forces through the anchor, like the shear forces through the anchor, and then it's kind of crushing this area here into the concrete. There are multiple ways to kind of help to this error or increase the capacity. One is like maybe adding some harpings, or maybe adding or increasing the concrete capacity. I believe we use 4 KSI. So then this is when the design process starts, right? It's when you start designing the reinforcement for this detail. Anyway, if we go to the summary, back to the summary, you'll see that stress flow, right? And then you can see also reactions and loads if you want to see that. And then for looking at the strength, we remember that here we have concrete results and then reinforcement results. The concrete you will see kind of outside results. However, you can create this section view, and this section view can show you what is inside this, kind of what is happening within this concrete block. So you can put it in these different planes. Okay, and then move it in the right one pose. 0 here. So we locate this plane where we have the sum of the anchors, right? So we can apply this, and then you will see the compressive, well, this is the utilization, okay? The utilization that we're looking here, and we apply this, and then we can change it. Let me close this view, and we can change it to the stresses, the stress calculated here, okay? If you go back to this section view, we can edit it, and then find what is the cross, where is the worst case scenario. In this case, it's here. Okay, so you can shift that plane there. Let me close this and uncheck the section view. So we are seeing now the outside. So these are the stresses on the concrete, the stresses that were calculated, the compressive stresses. And if you click over the reinforcement, then you can see also the utilization ratio, stress versus Fy limit. Fy limit, remember that it's the Fy that you pick for the reinforcement, then multiply by that factor. And also it can be seen here that that bend bar is not shown there, right? So remember, it's just a graphical representation, okay? All right, so here you will see that some of the stirrups are the ones, or the higher utilization ratio. Those are the ones that are more engaged by the forces, right? So this is utilization. So if we change it to stresses, then you can see what is their stress calculated on them. Okay. Finally, we can look at the anchorage results, and then you will see the stresses here. There you go. It was loading. So the anchorage, as I mentioned, I believe during the demo, is basically the bond stresses divided by the bond strength of the reinforcement. So instead of calculating development length, we are using the actual bond stress. The development length was kind of created, or the development length formulas were created to, instead of looking at the stresses, you can look at a length, right? So it was kind of transforming the bond stresses to a length. So in this case, we are calculating the actual bond stresses of the reinforcement. So you can hover the mouse and then see the force that it's the total force developed in the rebar, right? And then here you can also turn on this different forces. So this is the limit force in the rebar. So the total force here is assuming kind of the force developed along the rebar, and then the force also developed at the end of the bar due to that end condition that we model. Okay. Well, this is kind of an overview of the results. Let us know if you have questions, and yeah, feel free to send us more another email with your questions. Thank you. Bye.